Hello, my name is Elsee, and today I'm going to be presenting about my bachelor degree project 1 entitled Mechanical Behavior Study on New Green Concrete based on unglazed roof tile waste. Before that, I am student from bachelor degree in Manufacturing Engineering Technology, Process and Technology, and under supervisions of respected Professor Madya Dr. Zulkifli bin Muhammad Rosli. Okay, so before we proceed to the main purpose of these presentations, I'm going to briefly explain about my presentations outline, what to expect in my presentations afterward. So the first one is I'm going to present about the introductions of this project, which include the background studies, the problem statements, and the objective, followed by the scope of the research. And the second one is literature review. In this topic, I'm going to explain about the topic that is related to my study or to my research, and I'm going to use this research as my guideline to do my project. So the third one is methodology. In this topic, I'm going to briefly explain about what is the method that I use for my project, what is the equipment, and the standard that I'm going to use for this project. So the following topic is results and discussions. In this topic, I'm going to explain about the comprehensive strength test analysis and grading URT analysis. As for my project, I have already done the partially of this project, so I'm gonna go more details on the results afterward. And the next one is conclusions and recommendations. Also, I'm gonna go through that more details afterward. So let's move on to the next slide. So the background study or the ideas of this research is where most of manufacturing industry are facing problem when it comes to solid waste management, especially for developing country in Asia. For example, in Malaysia, we can see that there are so many constructions still on progress, and this issue need to have an extra attention because it could affect the environment badly. At the same time, the development of the construction, this could affect the waste that is produced by this construction accumulated from time to time. As for this particular manufacturing industry, or to the specific roof tile manufacturing industry, they are facing a problem with their solid waste management, where the defect of their roof tile is accumulated from time to time and it leads to waste. It also become a problem to them if they do a rework on the roof tile, which affect the quality of the roof tile and also costing them in financially. Based on the background study and the problem statement that I have mentioned before, I have come up with two types of objective. The first one is general objective, and the second one is a specific objective. So in the general objective, is about to recycle the URT into green concrete product. As for specific objective, the first objective is to transform the URT into fine aggregate as a substitution of fine aggregate in concrete mix with the accordance of British standard by using a few methods that I have proposed in this project. The second objective of this project is to assess the mechanical behavior of the produced green concrete based on URT waste, is where I apply the methodology to determine the mechanical behavior of the produced concrete. So we are now reaching at the second part of this presentation, where I'm going to explain about the research paper that I have been using as a guideline for my project. By referring to the table on my slide, I have sorted out three types of material use with the same method and similar objective. So the first one is by Juan in 2011. He used ceramic waste as a coarse aggregate. To determine the mechanical behavior of the concrete, he uses comprehensive testing and modulus flexural testing for the hardened concrete, and water absorptions to test the fresh concrete properties. And the outcome of his research is that the mechanical behavior is improved compared to the natural aggregate. And what I can conclude from his finding is that the ceramic waste have a special properties that could partially substitute the natural coarse aggregate. The second research study is done by Kisei and Miyazawa in 2019. They are also using the same testing method as one in 2011, which is comprehensive testing, modulus flexural testing, and water absorption to determine the mechanical behavior and the physical properties of the concrete. But they are using different type of material, which is recycled rooftile as a coarse aggregate. Their research study is almost the same with mine, which I'm using the same material, recycled rooftile, as a fine aggregate. Meanwhile, they are using it as a coarse aggregate. Unfortunately, for Kisei and Miyazawa research study, the outcome of the research is that mechanical properties of the green concrete need more research and testing. What I can conclude from their research study is that it could be affected by the weather or the ambience, which can influence the properties of the concrete. This is because they are testing their project in cold weather. Unlike in Malaysia, we have a tropical weather. The third research study is done by Bmmp in 2019. He uses recycled plastic as a fine and coarse aggregate, and also using fiber on fresh concrete. He also used the same testing method as Wan and Kisei, which is comprehensive testing, modulus flexural testing, and water absorptions. The outcome of his study is that the plastic has poor bond capacity, and the characteristic of the plastic influence the concrete mechanical behavior. What I can conclude from his study is that they need to do more research on the long-term properties of recycled aggregate and need more research and testing. We are reaching the third part of this presentation, where I'm going to explain about the method that I'm going to use in this project. So the first one is concrete mix design. Concrete mix design is where the proportions of each component in the concrete is calculated and must be in accordance with the British standard. So here is the flowchart of the concrete mix design on how it's actually done. Alright, so moving on to the second methodology of this project, which is concrete molding. In this mixing, I have not used any URT in the mixing yet because I have to determine the right proportion for the concrete mix before including URT in the mixing. After the process of concrete molding, the next process is to let the concrete cured for at least 28 days. After the 28 days, compressive strength test will be conducted on the cubic concrete. This is the video on how it's actually done. The following methodology is about crushing the URTW using 3 different types of machines. The first stage is that using crushing machines, second stage is that using grinding machines, and the third one is using planetary ball milling machines. URT is my main raw material that I'm going to use to produce the new green concrete. Also, the reason to use 3 different types of machine is that we receive the raw material from this particular company in a big and large pieces of roof tile. After the URTW crushing, the next process is shift analysis and particle distributions. The first pictures in my slide showing that the URT the crushed URTW is placed in the sheave stack, and then the second picture showing that the sheave is placed on the machine vibrating sheave shaker for at least 10 minutes. And lastly, you can see that the particle is retained at each compartment of the sheave. And here I have the results for the compressive strength test for the cubic concrete. But actually I have done 2 trials for the compressive strength test, because the first trial is not meeting the standard strength of British standard. Meanwhile, for the second trial, the strength for the average after 28 days exceeded or passed the standard strength for British standard. This is the second result for my project this semester, showing the sheave analysis and the particles distribution for URTW. If you can see in the graph, the dashed line is stand for the lower and upper limit of the passing percentage in sheave analysis. By referring to the grading fine aggregate graph in this slide, the blue line for the second batch is of the upper limit a little bit on the 0.5 sheave size. However, for the first batch, the particle distributions are within the limit, which is good. That's it for the result of my initial project for this semester. So let's moving on to the Gantt chart. This is the Gantt chart for the next semester, and it seems that most of the plan is not done in actual because of the pandemic that everyone is facing and the situation that we are all in right now. But hopefully in the next semester everything is going back to normal and can proceed with the testing and mixing for the concrete. This is the Gantt chart for next semester, and everything is already planned, and hopefully whatever is planned this semester could be accomplished in the next semester according to whatever is planned for this semester. To summarize this semester progress, this is the project milestone that I have already achieved in 14 weeks. By looking at this project milestone that I have already achieved, for the first week until the 5th week, I successfully select a research topic and define the topic and also propose the methodology. Next is in the 5th to the 8th week, I have successfully conducted the research and explore more about the topic by doing a literature review. And the next one is that in the same durations, 5th and 8th week, I successfully implement the proposed methodology and conducted the experiment as I mentioned and showed in the earlier presentations. Next is in the week 9 to week 11 is where I successfully compute and analyze the obtained data from the experiment conducted. And last but not least, for the 12th week and the 14th week is where I summarize all the results and planning for the project in semester 2. We are reaching at the end of these presentations, and what I can conclude for this semester project is that I need to be more focused on the proportions of the cementitious material when the URT is finally added in the mixture. Other than that, I also need to be more focused on the grading of fine aggregate, since the the second trial for the particle distributions is off the limit a little bit at the 0.5 millimeter. By judging from the methodology that I have chosen for this project and the result that I have obtained from the experiment conducted, I can confidently say that I could achieve my objective at the end of this project. So I think that is all from me about my presentation for study of mechanical behavior on new green concrete based on Rooftil West. Thank you.